Hey guys, what's up? Somebody give me a 5 for 5 and we'll crack a lacquer with it, okay guys? I don't expect this one to be very long. We've had an eruption on the sun that's coming right at us, so we're going to talk about that. Okay, cool. Hey Flaming, hey Seven, hey Joanna, to Tim, Trish, what's going on? Sarge, Christopher, Kieran, RJ, back at you, Flaming. Love you too, brother. Virginia, Deb, Pamela, Survival Game. So we're just going to go ahead and jump into this because I realize that it's Friday night and most people are, Hey, John. But I'm going to put my chat away for a second. I'll check back in on us. And I'll check back in on you guys here in just a few minutes. But, So, I forgot what I was going to say there. Hey, Sid, good to see you. Okay, so I am clicking on that. So, I trust my mods in there. Guys, you guys are awesome. So, please keep it under control. And I know you guys will. So, we did have a pretty decent-sized filament eruption. And again, like I said, we'll talk about that like right now. We talked about this a little bit yesterday. Well, actually quite a bit. But NOAA has updated now. Remember yesterday, it stopped at the 14th. And we didn't have any more data. But we had another big flare right here. Okay. So that was that flare. It's the same flare I showed you guys yesterday. It's on my thumbnail. But now it's here on this data dashboard here on NOAA. Now notice we're still getting these little bit of flares. But if you guys remember what I said yesterday about the big long filaments stretching across the face of the sun, right? I said, hey, we're going to have to watch these. These are the ones that we need to pay attention to. The sunspots and stuff we always look at, but the filaments sometimes they take a back seat because people can't see them as well, and they just typically are not talked about enough, in my opinion. Because when they lift off, it is a CME. It's plasma getting flung out into space. So, let me check on the chat here for a second. Hey, Miss V. Pamela, Joanna, yeah, okay. So, Virginia, what's up? Now, okay, putting it back away. Just want to say hi. All right, so as you can see here, guys, geomagnetic activity, we are on the rise. Now, what we need to look at when we see that kind of stuff is we go up and look at NOAA's forecast. Okay, so on the 16th, which is starting right now, they're saying we should be at a 3 on the KP. That's just a number they give it, and it's just a way to be able to chart how strong something is. But what I want to point out on this, if you guys look right here, R1, R2, R3, right, or greater. That's the amount, that's the percentage within this day on the 16th. There's a 45% chance we could receive a R1 or R2 radio blackout conditions. That's actually fairly high, okay? What that means is they're predicting a solar flare, or forecasting there's a 45% chance of a solar flare to be this R1 or R2. So we're talking M class. Now, if it gets to R3, that's X class flare, right? And there is a small chance for that. And, the sunspots on the sun are definitely in a magnetic formation right now, a few of them. They're starting to intermingle, with the polarities. So they become unstable, like I talked about yesterday, and that's when they, bam, 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 right? And as you can tell, these here are not being quiet. Now, if you remember back in solar minimum, about last year and a half, maybe 2 years ago, remember this baseline? I haven't talked about this for a minute, but the baseline here was, down here. Even down here. It kind of looked like this one because we had no sunspots. So it doesn't take much more X-ray to get us up into these storm levels. So that's why we pay attention to it, because that does matter. So I wanted to point that out. Now, we're going to have a geomagnetic storm. I really think we probably will off of this one. How big or how small, that I cannot tell you. Okay. Now, this is GOES 16. This is the GOES satellite system that they use. And I'm going to display this because it's just a short one here on NOAA. They don't put a whole lot of images in here. But I'm using the 195 angstrom here. It's looking at that gas here on the sun. And we're starting to see these holes open up now too. These are rotating in. And you can even see on this one that these are active. You won't see the flares and everything as well on this one typically. But you see this? That's another filament. Okay, it's just arcing up. All these little swirls. That right there is a pretty complex thing, sunspot. These over here are even more so. This is the one that was firing off yesterday. And we had the one that fired off here. Well, guess what? The filament that was attached to that eruption yesterday lifted off today. And that's what gave us the CME. Now, here are the sunspots, and we'll look at the filament here in just a second. I want to show you guys this first. As you can tell, these things they're starting to, the ones that are, you would think that if you're looking at it, this would be our big issue, right? Because it's bigger, looks more impressive. Well, it's really not, because the magnetic signatures inside of this thing are not really there for big flares. So even this little smaller grouping, see those little dots right there? Those are sunspots. It's a sunspot group. These and this one here, in my opinion, have a better chance of producing substantial flare. Now you can see right here, now this was not forecasted either, I don't think. This is solar wind, and I'm not going to take you to the Discover data because I can just show you what I need to right here. This is the speed, and it's up to like 600 right now, which between 3 and 500 is normal. What we would consider not to have to really pay much attention to. Anything outside of that, even low, is not the best thing for us, because when we have low solar wind, it lets our KP drop, and if we get down into these KPs are down on 0 for any length of time, like a day, cosmic rays that are not coming from the sun, they can, but cosmic rays outside of the sun start penetrating. This is what I mean when I said the sun actually helps protect us from the sun and cosmic rays, which is radiation essentially. Okay, so I just wanted to point that out. And again, guys, I'll check on the chat here in just a second. I don't want to get distracted because you guys know me. Anybody that's been here for a minute knows that I get a little off target for every once in a while. Is what it is. There is no script going on here, so that's why I don't do that. I do that for a reason, guys. I want it to be, natural. I don't want it to sound like, some big time forecasting formal type of thing. Unless I want to do a video like that, right? But my normal stuff, there ain't nothing wrong with doing videos like that. But for me, I like it this way because I do think people actually learn more this way because they're not being talked down to. You know what I mean? It's not like being in a class listening to a professor. And again, there's nothing wrong with that. Well, actually, Tamitha Scove, she does different types of videos sometimes. She'll do what she calls an informal update, which is kind of what I'm doing here. Or she'll do a formal one, which is really, she does it really well. It's all put together really, really well. She is very highly educated on the subject. It's free college, guys. Go check it out. I'm telling you, it really is. And the benefit of that, you can stop and rewind and pause and all that stuff. So if you don't understand something she's saying, you can actually stop and go figure it out. And I'll say this too. I say this a lot too. You guys are smart enough. You really are. I believe everybody here is smart enough to understand if you really, really want to. I ain't going to say that you ain't going to make mistakes because I make mistakes every day. It's just when you get to a point where you're able to accept that you made a mistake, you could come out and teach somebody from that mistake that you made. So that makes you a better teacher. It makes you a better whatever, being able to have a mind that is able to accept new stuff, or accept the fact that you were wrong. It's not, you know what I mean? So, anyway, so this is the eruption. This was the thumbnail. I'm going to push start. Oops, it's on reverse again. All right, so now we oftentimes talk about the word halo when we're talking about these CMEs, right? So I'm going to pause it. And this is the occulter disk. I explained this yesterday. This is on SOHO, which is a satellite looking at the sun about 1 million miles closer to the sun than what we are. So when there's an eruption, this occulter disk is an actual physical disk on the camera that blocks the main part of the light. If we don't have that, we don't get a picture because it gets flooded with light. So they put that there, and when they say halo, they're talking because of this. This is what they're considering the halo aspect. Okay? Because when it's coming like really directly at us, like symmetrical, it truly does look like a halo around this occulter disk. But this is still a halo eruption, which means nothing more than what I just said. It looks like that. It doesn't speak to the power of it. It more so speaks to the direction that it's traveling. Because if you're right in front of it and it fires right at you, it's going to look more like a halo. We had a stealth CME last week or a week before that was a very, very dim looking halo that most people missed. And we got a geomagnetic storm out of it because it got swept up in the solar wind and it hit us all at the same time. And are very close to one another. So yeah. And that's why they call that a halo. Now, this is from our perspective, right? Like I just said. So what we can do is we can go over here and look at our partial side view, which is stereo A. And you can see there was another eruption. I'll show you that one here in a minute. But this is that one. Now, again, let me say this. Earth is over here. So this does look to be coming at us. I don't think it's going to miss us. And when I show you SDO, you'll even think that even more, in my opinion. But, so you see that, and I'll slow it down. And again, that was a very substantial filament release. So, yeah. Let's go ahead and go back this one up a day because there was an eruption over here yesterday, and I talked about this yesterday. But here's that one, and it finally got the rest of the data in here, and it went ahead and fired on out. So that was not coming at us. That was from that M flare that I showed you guys earlier. Okay, so let's just get this keyed back up. I guess I'll tell you what we could do right here. We'll do this. This is yesterday also. Okay, notice all the eruptions that are happening. They're just nonstop. They're all over the place. And don't forget, the day before this, what do we have? This is our sun diver. Okay, so we've got activity, guys, and it's just not gonna slow down. You know, this sun diver, and the sun did eat this one up. It's confirmed. It was not a sun grazer, which means it didn't skirt the sun and go back out into orbit. This thing is gone now. It ate it up. Now, there's question whether or not that kind of enticed the sun to erupt right there, and I talked about that yesterday. I think the timing of it does kind of suggest that, but there's really no way for me to tell. I don't have those kinds of tools to look at. I imagine there's something out there. I just don't know which ones to go confirm that with. So, just so you guys understand that now. Okay, so here we go. This is the one I showed you guys. This is SDO again. And this is the extreme ultraviolet light, and it's 304 angstrom of light. So we're looking at, I think this is ionized helium, I believe, if that's the right gas we're looking at here. But the filament is here, and it's a big one. Okay, and again, I showed you guys this very filament yesterday. So I'm going to back that up, and we'll just kind of look at it together. And what's kind of significant here, and I'm going to go ahead and just zoom in a little bit more because you guys are going to see it like spinning and twirling out. And so here's my cursor. Let me do this again. I have to do it this way, guys, so I can use my directional keys on my keyboard so I can have this here with my cursor on the screen. Anyway, Okay, you see how that kind of jumped? Because there is some missing time there. Not much, but it's there. So here's the filament, the dark channel. It even actually goes all the way over here to this sunspot. See that? So let me, if you look right here, this filament lifted off, but watch right here. See that? What looks to be like a cloud of whatever color we want to say it is. Okay, that's plasma. See it spinning? Look at that. And I'll just, see that? Wasn't that cool? I am sorry, that's cool. You know what I mean? I mean, come on. If that ain't cool to you guys, I don't know what cool is when we're talking about space weather. And I may not. So, anyway, right here. Now, let me back this up because I want to show you something. Because this happened in another filament eruption. You see that? Here's the filament. Watch what happens when this releases. You're going to see the channels on the surface kind of open up, or at least in the corona. See? We talked about this yesterday. Hey, Paul, how you doing, Mr. Bagley? Doing okay, bud? Hope y'all doing good over there. Hope everybody's doing good. We all need to, got to pray for one another, guys, and love everybody, and that's where it's at, This isn't really nothing to be afraid of, guys, just so you guys understand. And so, yeah, it is substantial, though. Check it out. That thing is definitely just, wow. That's all I can say. Yeah. It's definitely substantial. That's all I'm saying. I mean, I really can't tell you how strong it's going to be, but that is something people need to look at because this could give us a geomagnetic storm. In my opinion, it's going to. And let me show you why. This is the NASA model. This is the Enlil spiral. We look at this often. And look at it. I mean, it's like dead right on us. I mean, the NASA model thinks this thing is going to be a direct hit. So, all three models here are showing it hit, like right in the middle. And this is the top-down view. The one in the middle is a side cut. And then the one you got here is your orbital line stretched out in a straight line. And the yellow dot here is Earth. And obviously that's the sun. So you can see that. Now, again, if that hits us just like that, we will be taking the middle of that, which would be the higher dense part of it. Now, this early on, sometimes they get it. The model gets it a little bit wrong. We'll just have to wait and see if it confirms tomorrow and the next day. You know what I mean? We do have some time to talk about this. This is why this is a good thing. CMEs we could talk about and give people little bits of warning on that. When you're talking about flares, the flare part of it, the X-ray, it's here or it's not. You know what I mean? It's here in like 8 minutes. It travels the speed of light. Okay? That's just what it is, and that's what we're going to do, right? We just got to pay attention to it. So, let me go ahead and we'll check out the Aurora real quick. I've been noticing, too, I'm not sure if there's any scientific explanations for this or not, but the southern lights, which is on the right here, they seem to be a little bit more intense than what the northern lights are right now. Now, it's probably because of the way the Earth is tilted, and the BZ angle matters too. You guys have heard me talk about BZ, right? That would be... Come on. Man, this thing is acting slow. Wow. Man, what did it do? Okay, I'll reload that, see if it does anything better there. Wow. I wonder why Noah's having issues here. Look at that. It's just loading really slow. Unless it's my internet connection. It shouldn't be, though. My internet should be good. But as you can see, guys, this is just wow. But let me go back. Okay, here it is. It's back. This is the BZ, right? -6 is what we look for. If it gets to that, that means it lets things in easier. Our angle of our magnetic field is in a position that it allows it to come in a little bit easier. So, hey, Miss V, good to see you. Hey, Leisure, I seen you in there a second ago, too. Guys, I'm just kind of slowly glancing over at the chat every once in a while. So, I'm sorry if I miss people. I'm not trying to. I just want to get this to you guys. If I don't stay focused, you guys know what happens. So, anyway, you can see the southern lights are a little bit more active right now, and that's what I'm talking about. So, that could be because of that angle we're talking about. See how this is a little bit more intense, or the forecasting here is. And I do think it probably has something to do with the angle of our, the BZ angle itself. It probably does. Because we are talking about magnetic connection lines, guys. And what happens is the highly charged particles, they get in. And when they get in, they excite the atoms that are there, the molecules. And that's your oxygen and your nitrogen is what we typically talk about. So it excites those. And when they're going back to their stable state, that's when they give off the light. So when they're, going back to the more just focused, their little stable ambient positions, just typical stable state for that particular atom. But when you're looking at that, that's what you're seeing when you see the color. So this is a model just trying to help you guys understand how far down they'll be. When we talk about mid-latitude, we're talking kind of like right here. You see this line? And so if you see that line, that's what they're talking about. That's the latitude line. I'm not sure exactly which one that is. That's probably the 60 degree or 30 degree. No, it wouldn't be 30 degree. 30 degree would be up here. That's probably more like the 60 degree latitude line. But when you start seeing those stretch down towards the equator, that's when we know we're getting hit. Or at least we have a crack in our magnetic field that's allowing stuff in. Down here, we could talk about the South Atlantic anomaly. That's always a weaker spot in our magnetic field. It's there. It's actually split in two, and it's spreading. So that all points to our imminent magnetic pole flip that we're going to be having. When that happens, I don't know. It's really hard to pinpoint that down, but everything is pointing to that. And that's just what it is, right? So, here is the geoelectric field model. Now, this is different, guys, okay? We're talking about geoelectric, okay, not geomagnetic. But they both will react almost at the same time. And I pointed this out the other day. You see this right here? It says USGS. This is actually a tool that they made that they're trying to perfect. This is a three-dimensional one over here that's not completed yet. It's still in like a beta testing phase over here. It's getting better. It's starting to work better. But we've had this one now for a couple years, and it works really, really good. But this was put there, and they're studying this. They're using this for earthquake predictions. Okay, they're trying to understand exactly how solar weather, space weather, affects us in the earthquake realm. Because we all know it does. It's just nobody can, go point to a directly an archived data point. At least not to the level that everybody's comfortable putting it into their models. And I think that that's where this is coming from. And I think that's why they're doing this. But this is a really good way to understand, because this model is representing how space weather is affecting our electrical grid. Okay? Because it tells you exactly what this is. It enables a side-by-side comparison of geoelectric field models. Okay? They synchronize this one part. The geoelectric field at the surface of the Earth indicates how much current will be induced in artificial conductors. Okay, so we're talking power lines, phone lines, railway lines, all those things. Pipelines. Okay, people forget that too. We got pipelines underneath our feet, transferring all of our, our oil and our gas and stuff. And I know that's a whole nother subject that I'm not going to touch right now, but that's definitely what's going on. So, you got that, the geoelectric field at the surface of the Earth, and that's what this is trying to show you. How this is trying to affect, and how it's going to affect our electrical grid. And these models are actually getting really, really good. As you can see here, this is a three-dimensional one, And the reason why it's brighter in these areas is because there's more electrical components. If you look at this, you'll see that they kind of match up with the populated cities. Okay? So that's kind of what's going on. But as you can see, I don't know, this one here isn't moving right now. I wonder why this is the only one. It might not be working. This one might not be. But, well, oh, there it goes. Okay. So you can definitely see. Now, when you see this, this is actually caused by the mountain ranges. Okay? You can see it over here on the Appalachians, too. You get like a void. I don't know if that's because the tool needs worked on or if that's actually what's happening. Now, I can tell you this, that this pointed triangle, that's not nature. Okay? That's something to do with they need to adjust the tool for some reason. And again, like I said, guys, this is just something that's still kind of in the beginning phases of this. They're trying to do studies and stuff on now. Spaceweather.com, guys. Again, they do such a great job over here. Please go give them some love. Dr. Phillips over here is just, he kills it. And it really is. It's a good, one of the best sites around, in my opinion. And it's not a YouTube page. This is a web page. It's in my description box every week. I don't even know him. Okay, guys? I've never talked to the guy. I just think that he does a really, really good job of what he's doing over here. And I like to share that stuff with you guys. So there's the link. It's in the chat. Hey, Miss V, what's up? What's up? So, yeah, I'm not going to say that word, Rizar, but yeah, that's, man. So, anyway, let's take a look at this eruption again, okay? Let me get you back to the same day. And let's go here. And so, yeah, that is what we would call, technically they would call that a partial halo. But if you could picture that thing, just rotate it maybe 45 degrees, that would be a full halo if it was in the right position. Don't be scared when you hear the word halo. Again, all it means is it's peeking out around this occulter disk. And if it's doing that, that means it's if we're looking from a satellite from our perspective, that means it's either coming right at us or it's going directly off the back. Okay? Yeah, Hilly. With you. Oh, man. Excuse me. Sorry about that. So yeah, guys. So I don't, I wanted to bring this to you guys. That's really why I came on. I just didn't need to, I need to focus on this because I'm really trying to help, be a little bit more precise in what I'm talking about. I want to, try to keep to what we're, what we're doing. So that really is the report I wanted to bring to you. But if anything else happens, I'll definitely be here and let you know. But again, guys, I'm going to say this, like I'm probably going to say it about every live stream now. Listen, none of us is promised tomorrow. None of us. Okay, we're not guaranteed that. There's one thing that we can't buy. You cannot buy extra time. You can't do it. You can't go back and change what you did with the time that you had. So please, don't waste it. Spend it with the people that you love because you do not know when it's going to end. Me as a Christian person, I have my own beliefs on all that, right? And a lot of people share those beliefs. And that's awesome for me. But I also recognize that there's people here listening that don't necessarily believe that. And that's okay. I'm all about that, right? Even if you look at it from a Christian standpoint, you really have to bring in the subject matter of, hey, didn't my Savior go into the house of the sinner? Because you're not going to go into a house of a saved person and save him again. You got to go to the place where it's bad. So what I'm saying is everybody needs to be just pay attention, and that's what we need to do. And don't waste the time that we're given. Don't. It's just not cool. You will regret it, I promise you. And like I said, guys, I don't know how much time I have left here. Nobody really does. If you really look at that, I've been going through some stuff on my end of things anyway, and it's caused me to recalculate in my brain where I need to be doing, what I need to be doing, and who I need to be doing it with my family, right? And again, and that's why I'm not going to commit to a daily report. I've done that in the past, and I wasn't successful in doing that, and I felt bad about that. So I'm not going to promise that, but I will promise you this: even if it's just a 5-second update, short or something big happens, I will tell you. I promise. That ain't going to change anywhere, never. And I just want people to love each other. I love everybody here. You guys know that. And I want everybody to just get to where they need to get, how they need to get there. And I'm not here to judge. I just don't. And I won't. And I never will. And I hope that you guys can, hopefully when I do things like that, people see me doing it. I hope it inspires them to be that way too. That's my hope. But, everybody has to find it their own way. And I don't have the answers for you. I really don't. When it comes to that, all I can tell you is my life experience. And within my life experience, nothing's promised. Okay. And again, guys, I wish I could go a little bit more personal and deep with you guys on that. I'm just not, I can't. And again, it has nothing to do with what's going on space weather or the internet in general or any of this stuff, right? It's just more so what I have right in front of me, what I'm looking at. And trust me, I've not talked to anybody about what's happening with me. I'm just not going to. So please, I would love to have your prayers and your love and everything and your good thoughts and all that. But please don't ask me about it, okay? I would appreciate that, and because I know you guys care, and that's why I'm saying this. Please don't ask me about it, because I don't, and I won't talk about this specific thing, right? But just know, guys, just pay attention to what's going on, and never no fear. We can't live in fear, never, ever, ever, ever. It doesn't do you any good. When you're in fear, what happens? You make bad decisions. You're fight or flight. So it's hard to make the right decision, and if you're fearful. And there's no reason to be. We can't control this anyway. So we prepare a little bit or a lot, depending on who you are and what you believe, and we just move on from there. But I will show you guys. I know you guys are asking about that thing there. Okay. I'll bring you back here and let you guys watch this to 304 while I finish up. And I'm sorry, I don't mean to rant, guys. I really don't. It's not my reasoning here. But as you can see, this again, here's that filament, and you're going to see when it releases off, it's going to miss a little bit of time. But you're going to see like a what do we want to call that? It's like I think they actually called it a canyon of fire. I really do. I think that's what they were calling it. But notice that there was another eruption over here too before that. These are happening all over the sun. There was even a small one down here. But watch when this filament releases off. You're going to see it exposed like a canyon of plasma. You see that? Right along the edges here. And this happened the other day. Remember with the winking sun? Remember I, brought that up? But, that was the analogy that Tamantha Scove used, and it was a good analogy because the coronal hole actually closed up after it erupted. And it closed up pretty quick. Now, this is going the opposite direction. It's kind of opening up, but that's what you would expect to see, right? Because most of the time, these filaments are not on the surface. They're above the surface, hovering over it. And when they finally get that stable magnetic connection or unstable, they will either erupt or they'll fall back down to the surface. And right now, this one here, you know, the little wisp of filament right here. It's cool. Watch. Actually, watch right here where my cursor is. Right. Already do it? Yeah, I was already too far. Sorry. I'll back it up. Right there. See that? Right there. And I just thought that was cool. That is that filament. And remember what I called it? I told you it kind of acts like a whip. And that's exactly what you seen there. Because the end of it's right here, and it flicks off this way, and it just released plasma the whole time it was flicking out. That's why we got that partial halo. Okay? So I do think this is coming at us. NASA, or this, at least this model, NASA's model agrees with that. I would think that the NOAA model, this is the same model, they just use different parameters. So we'll wait on this one. It hasn't updated yet. And then if they agree, typically, we better be paying attention. So that's just kind of what I would say to all of that. Now, all right, guys, I am going to go ahead and end it. I hope you guys have a great weekend. If anything else happens, I will be back on here. Go watch all the people that I always promote, guys. I'm not going to go through the list right now. But just know that, you know, we can't control it. No fear. Be aware. Prepare. Pray for Rip, too. Rip Curl, guys, he's been having some health issues, or his family has. And, you know, we got to pray for each other and send love and good thoughts and stuff, whatever your thing is. And I 100% believe it helps. Okay? I've seen it. So, anyway, I'm not going to go into that. But just know that I'm here because I love all you guys, and I want it to try to be here for you as much as I can. So, we will go ahead and end it there. God bless. Yahusha saves, and what do we always say? You can drink this Kool-Aid.